脑人言。
今天我们很荣幸请到了上海神经所的张文怡博士，博士研究生，来给我们介绍他最新的在 Nature Communication 上面的一篇文章，主要研究的是奖赏和注意在前额叶的表征。这个奖赏和注意在他们之间的关系，实际上已经争论了很多年了。我记得在很多年以前 ，John Mansell 就专门写过一篇文章来介绍这个奖赏和注意之间的关系。到现在可能也没有什么特别好的定论。然后今天我们请张文怡博士来介绍一下他的工作。
哎呀，可能要稍等一下，我这个屏幕共享有点失败。
好，没关系，没关系。
对。
如果大家有什么问题，在他做报告的时候可以随时提问，或者在 chat 上面也可以留言。如果您不能说话的话，在 chat 上面留言，然后我会转达大家的问题。
So it's an honor to be here to introduce our latest work about word silence, but now spatial attention dominates value encoding in the orbitofrontal cortex. So imagine that you are looking for books about neuroscience in a bookstore. Your selection might be guided by top-down attention or straight to specific bookshelves and make a decision. Your selection might also be guided by bottom-up attention, being attracted by some bestsellers placed in obvious locations with attractive covers. So to review the neural mechanism of value-based decision-making, we need to know how attention modulates value encoding in the brain. And previous study found that orbital frontal cortex is a key brain area in the value-based decision-making. This is a study from Purdue's Yelpas lab. In this study, monkeys were required to make choices between two juices. So here, the taste of juices were indicated by different colors, and the number of squares indicates the amount. When a goal cue dims, monkeys were required to make eye movement to one of the corresponding targets to indicate their choice. And the reward associated with the chosen option will be delivered afterwards. And the right panel shows the proportion of trials that monkey choose juice B in different pairs. And by fitting a sigmoid function, we can know that the monkey prefer one drop of juice A and around 4 drops juice B equally. With the indifference point, we can represent juice A and juice B in a common unit. They also recorded neural activities from orbital frontal cortex. And this is an example neuron encode the amount of juice B's. So here we can find that when the amount of juice B get larger, the fun rate was higher. They also found some neurons encode the chosen value. So here we can see that when the chosen value was higher, the neuronal responses were larger. And the chosen value neuron were indifferent of the absolute amount of juice A and B. So it seems that the input and outputs of value-based decision-making are both encoded in the OFC. Previous study also shown that the value encoding in OFC were modulated by the viewing distance. So in this study, a reward associated cue will be presented on the screen. So here, different color indicate different juice amounts. And during the cue period, monkeys were allowed to look at the cues freely. And they found that the value signals in OFC were modulated by the viewing distance. For those neurons, when the fixation distance was short, the value signals enlarged. They also found some OFC neurons showed opposite firing patterns. And another study, which is from our lab, shows that the value signals in RFC were modulated by covert attention. So in this study, two word-associated cues were presented on the screen. And in some trials, one of the two cues rotated to attract bottom-up attention. And they found that rotating higher value cue evoke larger neuronal responses in RFC. And when rotating lower value cue, the neuronal responses were lower. This is the firing pattern for positively tuned RFC neurons, and the negatively tuned RFC neurons showed the opposite firing pattern. So in those studies, it seems that overt and covert attention modulates value encoding in RFC. However, there are some problems in those studies. The first thing is they did not carefully measure the location of the attention. They just assumed that it was from gaze location or physical silence, but without clear neurophysiology markers of attention, they just provide indirect evidence for the proposed theory. The second thing is that in sheer study, it seems that the bottom-up attention modulate value signals. How about top-down attention? Previous study claimed that maybe bottom-up and top-down attention are from different sources. So we are wondering whether top-down attention also modulates value signals in RFC. So to answer these two questions, we need to record neuronal activities in a brain area that reflect top-down spatial attention. And DRPFC is the brain area we're looking for. So in this study, monkey were directed his attention to one of the 4 Gabor stimuli. And they need to report the orientation change at the target location and ignore the orientation change at the distractor. So how they know which stimuli was the target stimuli? So there was a cue presented in advance. So the cue location was the target location. And after the cue onset, there was a delay period. During the delay period, 4 identical Gabor stimuli would be presented. And they decode monkey spatial attention signals during the delay period with the neuronal example of DRPFC responses. And they found that the decoder achieves high decoding accuracy, indicating that top-down spatial attention were well reflected in the DRPFC. So I introduced a lot of backgrounds. So what we are going to answer is how top-down spatial attention modulates value encoding in RFC. How are we going to answer these questions? So we design a visual detection task. In this task, 2 word-associated stimuli will be presented on the screen simultaneously. And they were associated with different words, for example, 8 drops of juice and about 0 drops of juice. And we direct spatial attention to one of the 2 visual stimuli. How we did that? We add a Posner queuing task. So after a random variable delay, one of the 2 visual stimuli change its luminance. And how the monkey know which stimulus is going to change its luminance? There was a attention cue presented in advance. The attention cue telling the monkey that the stimulus on its opposite side were more likely to change the luminance. So the stimulus on the opposite side were called the cue stimulus, and its value were called cued value. And since different stimulus were associated with different word, they had different word salience. So the stimulus associated with larger word called salient stimulus, and its value called the salient value. And to minimize the effect of word salience influence on attention, we had this word delivery route. So at the end of correct response trial, the computer randomly selected one of the visual stimuli and is associated with word with the believer. So in this example trial, monkey had 50% get 8 jobs awarded and 50% get about 0 jobs. And we knew that the top-down spatial attention were well represented in DLPFC. Therefore, we record single neuron activities in DLPFC. And if monkey spatial attention was successfully manipulated in our test, we might observe that attention would be shifted from attention cue location to its opposite side, which is expected to have a luminance change. And we also know that the value signals are encoded in OFC. Therefore, if top-down spatial attention modulates value coding here, we might see that the cued value dominates the value signals in OFC. So I'm wondering if any questions here, because I think it's a little bit complicated. Okay.
Do you have any specific reason why the cued location is opposite to the target location?
Okay.
Do you want to?
Because if the cue location was on the target location, then we cannot say it was from top down because it could be a bottom-up signal here, right? Because the cue appeared before. So if the monkey had to shift its attention from the cue location to the opposite side after the cue offset, we can claim that it was from top down.
Okay.
Yeah. So I'm going to go through the task design again. So at first, it was an attention cue appear on the left or right side of the screen, then comes to word associated stimuli. Then the cue disappear, and one of the stimuli change its luminance. It's more likely to happen to the stimulus on its opposite side. We call those trials value cue trials. There were 80% of trials the luminance change on the opposite side. In the rest 20% as a control, the luminance change on the same side of the attention cue. And at the end of the correct response trials, the computer randomly selected one of the 2 shapes and its word would be delivered. To encourage the monkey to learn the stimulus with word association at the beginning of the training, we train the monkey to perform a single stimulus trials. So in this trials, only one with word associated shape were presented on the screen, and it was always on the opposite side of the attention cue. At the end of correct response trial, the word associated with that stimulus will be delivered. So, okay. In the next few slides, I'm going to introduce monkey's behavior. So we found that in the value cue trials, which the luminance change on the opposite side, monkey achieve higher accuracy compared to the invalid cue trials. And we also observed that the word salience had an influence on monkey's hit rate. So we found that when luminance changed on the salient stimulus, the hit rate was higher. And to compare those 2 effects, we also compared the hit rate when the luminance changed on the cued non-salient stimulus and change on the uncued salient stimulus. And we found that the former location had a higher hit rate, indicating that the spatial attention effect was higher. And we also look at monkeys' reaction time in those 2 conditions. And we found that monkey respond faster in the value cue trials, and the word salience have no effect on monkeys' reaction time. So from the behavioral result, we are sure that monkey allocates their attention properly, and then we are going to show some neuronal responses from DLPFC. And this is an example of DLPFC neurons. So we can see that after the cue onset, left attention cue trials had larger responses compared to right attention cue trials. However, after the cue offset, the firing pattern reversed. Now the right attention cue trials had a larger firing rate compared to the left attention cue trials. The inverse indicating that monkey's attention shifted from the attention cue location to its opposite side. And we record 406 DLPFC neurons from 2 monkeys. And to put neurons with different spatial selectivity together, we construct pseudo-neuronal examples and use an LDA decoder to decode attention cue location. The heat map shows the decoding results. So here the color indicates posterior probability, and the S-axis indicates when the neuronal responses were used to train the decoder, and the Y-axis indicates when the neuronal responses were used to test the decoder. And we found that the decoding accuracy were pretty high, indicating by the yellow area along the diagonal. This phenomenon indicates that monkeys' spatial attention were well decoded from DLPFC neurons. To test its significance, we also compare with the shuffle data. So here, the black line indicates the decoding posterior probability calculated from the true data, and the dashed line indicates the shuffle data. And we found that after the cue onset, spatial attention signal were well represented in DLPFC, about 80% posterior probability. And we also observed that there is some below trans level decoding accuracy, indicating by the dark blue area here. This is the decoding result with the decoder trained from the 200 milliseconds before the cue onset and tested with the responses after stimulus onset. So this result will also display in this panel. So we can see that 200 milliseconds before the stimulus onset, the decoding accuracy were about trans level, and then it dropped below the trans level. So this phenomenon indicates that the monkey's spatial attention shifted from the attention cue location to its opposite side, which is expected to have a luminance change. And this phenomenon were also observed here, which is the responses trained during the stimulus period and tested during 200 milliseconds before the stimulus onset. Okay. And we also found that the decoding accuracy correlates with monkeys' behavior. So according to monkeys' reaction time, we divided trials into quick response trials and slow response trials, indicated by the black line and the gray lines. So we found that the quick response trials had high decoding accuracy compared to the slow response trials, indicating that in the quick response trials, monkeys were more likely to allocate his attention properly. Okay, from DLPF's results, we are certain that monkey allocate their attention properly. Then we look at the value signals in OFC. So to measure the value selectivity in OFC, we look at the responses in the trials when 2 identical stimulus were presented. We call those trials same value trials. In those trials, monkeys are certain how much reward they would get at the end of the correct response trials. And we can see that this is a positively tuned RFC neuron. So higher fine rates when the higher reward stimulus were presented. And we also grouped the trials by the salient value, which is the larger value. For example, when the salient value was 8 drops of water, it contains trial types of A versus A, 4, 2, 1, and 0. And we found that the neuronal responses were also well separated by the salient value. And then we tried to compare those two groupings. And we found that the neuronal responses in those two groupings look similar, indicating that the salient value dominates the neuronal responses in OFC, and the non-salient value were almost ignored. And how about the Q and uncued value? So we group trials according to Q and uncued trials indicating by the red and the purple lights. And we found that the neuronal responses evoked by the Q and uncued value were almost the same, indicating that the spatial attention modulation effects were very weak in this example neurons. Before we performed the population analysis, we tried to classify positively tuned and negatively tuned RFC neurons with linear regression. So here, in each RFC neuron, we perform linear regression with variable listed here. So the single variable include value in single stimulus trials, lab value, right value, etc. And the table shows the number of neurons that were significantly tuned to each variable at each time epoch. And the positively tuned neuron would be defined as those positively tuned to at least one value variable at least one time epoch. So we have 83 positively tuned RFC neurons and 53 negatively tuned neurons. And we pool all the positively tuned neurons together and perform the same analysis as we did before. And we found that same value and the salient value evoke similar neuronal responses, just as what we shown in the example neuron. And also we found that the Q and uncued value evoke similar fine rates. The similar firing pattern were also observed in the negatively tuned RFC neuron, indicating that the salient value dominates the neuronal responses in OFC. To further quantify this phenomena, we perform linear regression with regressors of attention cue location, salient value, non-salient value in each time epoch. And we calculate the coefficient of partial determination, which is used to measure how much variance were explained by each variable. And we found that after the stimulus onset, salient value were significantly represented by OFC neuron, and the above trans-level CPD maintained until the end of the trials. And we also found that the CPD of non-salient value were very low, and it was not significant at most of the time points. This is the CPD calculated with the average neuronal responses during the whole stimulus period. And the yellow dot indicates the neurons that were selective to salient value, and green dot indicates those selective to non-salient value, and the black dot indicates selective to both variable. And we found that almost all the dots lie along the salient value axis, indicating that the salient value was significantly encoded in the brains. And the distribution of CPD were also displayed here. So the upper panel shows the CPD of salient value, and the lower panel shows the CPD of non-salient value. And we also found that the CPD of salient value was significantly larger than the CPD of non-salient value. And we also performed a similar linear regression with regressors of cued value and uncued value. And we found that the CPDs of cued value were similar to the CPD of uncued value at most of the time points. We also observed there are two significant areas, which is around the Q offset and luminance change. However, during those two periods, there was an external visual input, so we could not say it was driven by top-down attention. And we also calculate the CPD with the neuronal responses during the whole stimulus period. And we found that the CPD will lie along the diagonal. The right panel shows the CPDs of cued value and uncued value. And with the t-test, we found that the CPD of cued value weakly but significantly larger than the CPD of the uncued value. Okay. So I'm going to summarize a little bit what we found before. So the first conclusion is that the value signals were dominated by salient value in RFC, and the top-down spatial attention modulations were weak in the RFC. So we show a lot of results about the value signals in RFC. How about the spatial attention signals here? So we perform similar analysis as we did in DRPFC. We're trying to decode the spatial cue attention in OFC. And so the x-axis are the response used to train the decoder, and the y-axis are the responses used to test the decoder. And we found that the decoding accuracy were very low, showing in the heat map. In the monkey tree, although it seems that when the cue was appear on the screen, the decoding accuracy was about the trans level. However, after the cue offset, the spatial attention signal did not maintain in the RFC neurons. The next question is whether value signal in DLPFC are modulated by spatial attention. There are two possibilities. The first one is many study indicates that the value signals in DLPFC might be inherited from OFC. Therefore, we might observe similar phenomena in DLPFC. However, unlike OFC, the value attention signal are well encoded in DLPFC. So maybe value signals in DLPFC are more likely to modulated by spatial attention. To testify these two possibilities, we perform parallel analysis in DLPFC. So this is the linear regression with regressors of salient and non-salient value. And we found that the phenomena were very similar as what we observed in OFC. So after the stimulus onset, salient value were well represented in the OFC. We also observed that the CPD of non-salient value were also significant during the early stimulus period. However, it was very low, and the significance did not maintain at the late period of the stimulus. And we also compared the CPD of cued value and uncued value. And this panel shows the CPD in the DLPFC. And we found that the CPD of Q and uncued value were also very similar at most of the time points. indicating that the spatial attention modulation effect on the value encoding was also very weak in the DLPFC. We also compare the value signals and spatial attention signals in OFC and DLPFC. So this linear regression, similar to what I mentioned before, were performed on the average neuronal responses during the period from the Q offset to the luminance change. During this period, the spatial attention were mainly from the top-down mechanism. And we calculate the CPD of salient value and attention Q location. And here, the orange cycle indicates the CPD from OFC, and the blue cycle indicates the CPD from DLPFC. And we found that in OFC, almost all the dots lie along the salient value axis. However, for DLPFC, the dots lie along both axes. And to further measure this phenomenon, we calculate the difference of CPD for each OFC and DLPFC neuron indicated in the insert panel. So we can find that the delta CPD was negative in the OFC neurons, indicating that salient value instead of spatial attention dominates the signals in OFC. However, the delta CPD was around 0 in DLPFC, indicating that DLPFC encode both spatial attention and value signals here. So I'm going to summarize a little bit. So we trained the monkey to perform a visual detection task. In this task, we direct monkey spatial attention to one of the two word stimuli. And we also record neuronal activity from DLPFC, and we found that the DLPFC neurons will reflect spatial attention, indicating that the monkey shift its attention from the attention Q location to its opposite location. After that, we also record neuronal activity from OFC. However, we found that salient value dominates the value signals here, and the spatial attention modulation effect on value encoding was very weak. Those results indicate that OFC might maintain a stable representation of word salience, which is minimally affected by top-down spatial attention signals. Okay. Yeah. That's it.